Hello there. We're on to the last lesson of our second unit, and like most of our units, we'll be ending with the rates of change. The graph of a polynomial function is shown below. Estimate the instantaneous rate of change in the function at the point 2, 0. Okay, so we want the instantaneous rate of change at this point. Now, in order to find the IROC, we have to know the equation. Okay, we don't know the exact equation here. We know some x-intercepts, we know the y-intercept, but we don't know the leading coefficient. Okay, so we're going to start with the roots. And we have a root at 0, we have a root at 2, we have a root at 4. Okay, and then each of these we need to know the multiplicity, so it goes straight through at 0, so the multiplicity will be 1. It makes a parabola, or curves back at 2, so this will be a multiplicity of 2, and goes straight through at 4, so multiplicity of 1. Okay, so we can determine that fx equals a. Sorry, we don't need brackets for the x-intercept of 0. But we have x minus 2 squared and x minus 4. Okay, now we have to pick a point on the graph to represent the x and the y. Here's a nice one here, and this is 1, 3. So let's use 1, 3 in order to solve for our leading coefficient. So 3 represents the y, 1 represents the x. Okay, so we get 3 equals negative 3a, which means that a is negative 1. Okay, so the equation of this function is negative x minus 2 squared, x minus 4. Okay, and we know that IROC, so it's asking us for instantaneous rate of change, is delta y, so the change in y, divided by the change in x. And we also know that it is, we have to use the h value. Remember that very small increment that we add to the x value that we're looking for the IROC. Okay, so it's f of x plus h minus f of x divided by h. Okay, and we're going to make h equals 0.001. And as you know in the question, it's asking us to find the IROC at 2, 0, so when x is 2. So let's work this out. So we're replacing each of the x's in our equation with 2.001, and then we'll do the same at 2. Okay, so at 2.001, then at 2, divide by 0.001. All right, so it looks in long form. So we have negative 2.001 times 2.001 take away 2 squared times 2.001 take away 4. All of that subtract negative 2 times 2 minus 2 squared times 2 minus 4. And then divided by 0.001. Okay, when we work it out in your calculator, you do the first part, we get 0.004, subtract 0 because that middle bracket of 2 take away 2, and then multiply everything by 0. Divided by 0.001. Equals 0.04. So I think I didn't add enough zeros up here. Okay, so very close to 0. So we can say, therefore, the IROC equals 0. Okay, and this is something that we need to know. So we can see that 2 is a turning point, and we just figured out that the instantaneous rate of change at 2 has a slope of 0. Okay, so what conclusion could we make about that? We can say any turning point on a graph will have an IROC of 0. Okay. Consider the function x squared plus 5x minus 6. Find an equation that will tell you the instantaneous rate of change at any given value of x. Okay. So this is a little bit like calculus. We're only going to look at it today. We're not going to delve into it too much. Again, we know that IROC is delta y over delta x, or f of x plus h minus f of x divided by h. Okay, and if we're looking at this specific equation, so we're going to plug whatever's in our bracket into the x's of this equation. Okay, so we have x squared, but we're replacing it with x plus h squared plus 5 times x plus h minus 6. And then we'll be subtracting the original x squared plus 5x minus 6. And all of that will be divided by h. Okay, when we FOIL out the first bracket, we're going to get x squared plus 2xh plus h squared. And when you distribute that second one, we have plus 5x plus 5h minus 6. And then we'll be subtracting, so minus x squared minus 5x and plus 6. All that over h. From here we can cancel out like terms that equal 0. So we have a x squared here and a minus x squared. We have a plus 5x and a minus 5x. We have a minus 6 and a plus 6. And that's it so far. Okay. So what we're left over is 2xh plus h squared plus 5h over h. And since all three terms on our numerator have an h, and we're dividing by h, we can cancel them out. We cancel one of these. Okay, leaving us with 2x plus h plus 5. And then we need to think about when we discovered IROC, when we look at the characteristics of IROC, we made a table and it told us the closer to 0 that we got, the more accurate our answer. So because of that, we can just assume that H represents 0. Okay, so if H equals 0 or very close to 0, then we can get rid of that and we end up with a linear equation of 2x plus 5. Okay, so therefore the IROC here of this equation is 2x plus 5. Okay, this is called a difference quotient. And why are we doing this? We're going to use the equation to find the turning point of the above function. Okay, so the turning point occurs when the IROC is 0. Okay, and we know for this equation the IROC also equals 2x plus 5. So let's make 2x plus 5 equal to 0. We'll isolate the x, we'll subtract 5. 2x equals negative 5. And we divide by 2. My apologies. So x equals negative 5 over 2. Okay, so what this means is the turning point occurs when x equals negative 5 over 2, so negative 2.5. Okay, now let's plug this into our equation. So we're going to plug in negative 2.5, and it was x squared, so negative 2.5 squared plus 5 times negative 2.5, take away 6, which gives us 6.25 minus 12.5, take away 6, and that all leads to negative 12.25. Okay, and again, what that tells us is negative 2.5, negative 12.25 is a turning point. Okay, and the last thing that we could figure out from this is it a maximum or minimum turning point? Okay, so let's do that. Is it a max or min? For that, if we have a number line with our negative 2.5, okay, we can pick numbers on each side of it. So let's say x equals negative 3, and just to make it easier, x equals 0. Okay, we'll try to figure out, we'll use those in our 2x plus 5 IROC. Okay, so IROC equals 2x plus 5. So let's plug in first negative 3. So 2 times negative 3 plus 5 gives us negative 1. So that means as it goes to the left, it will become negative. And then we have in the second one, when we plug in 0, we get positive 5. So to the right of negative 2.5, it's positive. Okay, so if we were to draw a graph, at negative 2.5 and negative 12.25. Okay, we know we have a turning point there, and it's saying to the left of it we have a negative slope, and to the right of it we have a positive slope. So therefore it is a min.